Hey everyone, Sebastian here, back again with more SAT math, starting a new series in which I do long videos covering all the types of questions within a certain category. So in this one, right, it's EVA, which stands for Evaluating Statistical Claims, Observational Studies, and Experiments. And there are 8 types of questions that fall under this category, right? And this falls under the data analysis and probability section. So if you know these 8 questions, you know the whole category. So the question bank has more than 8 questions. I think right now it just has 10, but it might grow. But these are the 8 types of questions. So if you can master these 8, then you're in a really good position. And I'm going to be doing for all of them, right? So like percentages, there's like 80 questions. And I've divided those up into like 50 types of questions, which I know is still a lot, but it still saves you 30. And it helps you see the connections across questions and helps you think about what you need to work on. So this should be very helpful. Let's try these out and you'll see how hard or easy they are. We'll start with the easy level, right? Represented by that middle letter E, and then we'll go from there. So in this question, right, members of student council wanted to understand the opinions of all students about building a new football stadium. The council surveyed 70 football players and cheerleaders. The survey revealed that the majority of those surveyed were in favor of a new stadium. Which of the following is true about the student council survey? A, it shows that most students are in favor of the new stadium. B, the survey should have included more football players. C, the survey is biased because it is not representative of all students at the school. And D, the survey should have consisted solely of the opinions of students who are not football players. Okay, so we want to think about what the survey was, right? And it was 70 football players and cheerleaders, right? So it's not the whole student body. It's just specifically people who were football players and cheerleaders, which doesn't feel totally random. And if it's not totally random, it's not going to work. So it's biased because it's not representative of all students at the school. So it's going to be C, right? Because it is biased. And the other ones just don't work, right? A doesn't work because it's not representative, so we can't make conclusions about it. D, you wouldn't want to have just solely people who weren't football players because football players are part of the student body, so their opinion should matter as well. It should be a mix of people who are and are not involved in football. And B, should have included more football players. That would have just compounded the problem, right? So again, not too hard. You just want to know the rules that you want to have a random sample without a bias, and you want to think about how this could be biased. Almost anything can make it biased, but here it's very clear, right? Football players would much more likely want a football stadium than non-football players. All right, so now we'll try this one, EVA, EB, right? So still easy. The second category of the easy section. So let's see. A research firm selected 300 people at random from a group of people who indicated that they enjoyed a particular show. The 300 people were shown a movie that served as the series finale and then asked if they liked the movie. Of those surveyed, 90% said they liked the movie. Which of the following inferences can be drawn from this survey result? Most people who like the series will like this movie. Most people who dislike the series will like this movie. C, exactly 90% of people who watch movies will dislike this movie. And D, at least 90% of people who watch this series will like this movie. Okay, so I could almost eliminate C right off the bat because it's almost never exactly right. There's always going to be some margin of error. So I'm going to get rid of that. Right, so those surveyed, 90% said they liked the movie. And who was surveyed, right? There were 300 people who enjoyed a particular show, and they were shown a movie, and then asked if they liked the movie, right? And 90% said they liked the movie. So most people who dislike the series would like this movie. We don't know about the people who dislike the series because we're studying people who like the series, so we can't say B. And then the at least, right, doesn't work. It's just saying 90%. We don't know if it's going to be greater or not. So it won't be D. We could make a more broad assumption, though, of A. Most people who like the series will like this movie, so it's going to be A. And again, it's about understanding what your sample is and what we can draw from that sample. What conclusions can we draw from this sample, right? So this sample was specifically people who like the show. So we can't draw a conclusion about like all people everywhere, or all people in the US or anything like that, or all people who dislike the show. We can only possibly draw a conclusion about people who like the show. All right, so now we'll try another one. Again, you'll see how these are all kind of similar, but there's little variations on them that make them qualify as different types, even though they fit under the Evaluating Statistical Claims section. All right, so now we have our first medium question, right, represented by the M. And it says, researchers conducted a survey on biology teachers in Louisiana private schools using a random sample. The teachers surveyed were asked to name the providers of rat specimens used in dissections. What is the largest population to which the survey's results can be generalized? So again, this one's asking which population we can draw conclusions about. So what's the population we're drawing the random sample from, right? Biology teachers in Louisiana private schools. So that's a specific group. So let's look at our options. All teachers in the United States, all private school teachers, all biology teachers in Louisiana, all biology teachers at private schools in Louisiana. So it's biology teachers in Louisiana private schools. So we can't just say all teachers. We can't also say all private school teachers, and we can't say all biology teachers in Louisiana. It has to be all biology teachers at private schools. Because private schools might have different funding, right, than public schools, so they have different providers. Louisiana might have a specific provider, and biology teachers might have specific providers. I mean, they're probably the ones who are really getting rat specimens, not physics or chem or English teachers, but we still want to be specific on that. If it had just said biology teachers in Louisiana, then it'd be all schools in Louisiana, right? But it's private schools, so the more they specify, the more we have to specify, okay? So there'll be D. Not too bad again. It's medium just because there's more like subtlety on what we're focusing on, but I don't think it's too big a variation in terms of difficulty from the easy. So now we'll try the next one. Okay, so now we're doing EVA medium B, right? So it's still medium, just a different type of medium question. And you'll see how this is separated into three options that we have to choose from. So that qualifies this as a different type, even though it's the same level. A research firm recently surveyed 1,200 people selected at random from a large fishing village in Indonesia and asked each person, are you happy with the prices the conglomerates buy your fish at? Of those surveyed, 84% said that they were not satisfied with the prices. Based on the results of the survey, which of the following statements must be true? 1. Of all the villagers, 84% are unsatisfied with the prices of the fish. 2. If another 1,200 people were chosen and surveyed at random, 84% of them would say they were unsatisfied with the price of the fish. And 3. If 1,200 people were chosen at random from a different fishing village, 16% of them would say they aren't satisfied with the price of the fish. Okay, so we're told 84% said they're not satisfied from 1,200 people at a random large fishing village, right? So we can only know about the people in this village, not about any other village. So we can eliminate 3 as something we could draw conclusions on. And then the one of all the villagers, 84% are unsatisfied. That's too specific, right? It could be approximately 84%, but it's not must be true that 84% are unsatisfied, right? So it's not 1. And then if another 1,200 people were chosen and surveyed at random, 84% of them say we're, again, you can't draw that conclusion. It can't be that specific of a conclusion. If it had been something like most of them are unsatisfied, then that could be true, but that wouldn't necessarily even be must be true. So when it says must, it has to be very specific. So it's actually not 1 either, and it's not 2, so the answer is D. Again, this one's testing your knowledge of how you can draw conclusions from samples and information, right? You have to be very hesitant when drawing conclusions. You can't just go willy-nilly and say 84% said this time, so it's always going to be that number. It's always an approximation. That's why there's margin of error, which is another section that we'll do a different day. But it's all about making some conclusions, but not being too bold or too strong with them. All right, so now we have our first hard question, right? And it is, again, not too bad, but there's a bit more subtlety, right? These just get more and more subtle in the way they're asking them. A sample of 30 doctors was selected at random from a certain hospital. The 30 doctors were asked about temperature conditions in the hospital, and 26 thought the temperatures were appropriate. Which of the following is the largest population to which the survey results can be applied? A, the 30 doctors surveyed. Well, we could definitely know about them, right? But is that the largest population? Let's see. B, all doctors at this hospital. C, all employees at this hospital. And D, all doctors in the city in which this hospital is located. So it's 30 doctors at a certain hospital. So we don't know about other hospitals, right? Which makes sense. Maybe other hospitals are too warm, other hospitals are too cold. Other hospitals just have different expectations from their doctors, so it's not going to be D. Okay, and then C is tempting, but there might be reasons why a doctor has different temperature requirements than, say, a receptionist, right? So because we're focused only on a sample of doctors, we can only talk about doctors. So it's not C. A, we can draw conclusions about, but it's actually B, right? We can do it about all the doctors at the hospital. So again, you don't want to be too specific here. This one's the first one where we actually have another level besides choosing the most specific answer, right? Because the most specific answer is just the survey itself, and that's not helpful. You want to be able to draw conclusions about things beyond the sample. Okay, so for this one, right, there's a table involved, and that's what makes it qualify as a different type of question, even though the question is very similar itself. Since you have to read a table, I'm categorizing it as something else because I want you to see the broad range of questions and not just be like, oh, these are all the same. This is a different question covering a different skill. If you know this and you know the other one and all these other 8 questions, then you'll be golden for this whole overall category. A teacher wanted to study the relationship between a student's scores and the number of hours that a student studies. For the study, the teacher selected 70 students at random from his classes. The table displays the information for the 50 students in the sample who studied no more than 6 hours. Which of the following is the largest population to which the results of the study can be generalized? A, all students who scored above 70 points in the round. B, the 70 students in the sample. C, the 50 students in the sample that studied no more than 6 hours total. And D, all students in his classes. So we see this chart, right? It gives us interesting information, the 50 students. And the temptation is to go with something like, well, B is not it, right? Because if it's just the students in the sample, that's not very helpful. And it's not about who scored above 70 points in the round, right? But the temptation is C, the 50 students in the sample that studied no more, because that's what we see here. But that's not his whole sample. His whole sample was 70 students at random. So because it's just 70 students at random from his classes, it's going to be all students in his classes. This is just like a red herring. We don't need this. It doesn't matter. So on these questions, you want to watch out for things where the information doesn't matter. You probably wouldn't have to read a chart like this. And if you did, right, it would be more specific, the question. So you see it and it's telling you only the people who studied 6 hours or less, but you have to remember that there was actually 70 students total, and we don't see that, but he has the data for that, right? That is part of the study. So this one I think is probably the trickiest one of all of the questions on this whole category. And if you can nail this one and understand why it's D, then you'll be great. All right, and here's one more. This is the C category, right? Still hard, not necessarily harder than the other ones. Like I said, B is probably the hardest one. But at the back of a US magazine, there's a QR code for an online survey in which readers can answer the question, do you support the new treaty discussed in the earlier article? The magazine found that 88% responded yes and 10% responded no. Which of the following best explains why the results are unlikely to represent the sentiments of the population of the United States? So here, right, we're told it's unlikely. So we're not trying to find out why, if it's unlikely, but we're told it's unlikely and we just need to know why. The percentages are too far apart to be plausible. That's not true, right? It could be a great treaty and everyone loves it or something, or vice versa, and everyone hates it. B, not enough people can use QR codes. C, those who responded to the survey were not a random sample of the United States populace. And D, it's not clear which treaty is being discussed. On a question like this, something like C is almost always the right answer, right? The wording can be different, but it's always about having a misrepresentative sample or a biased sample. You want an unbiased sample, but if it's not going to represent it, that's because it is biased, right? So what's the bias here? It doesn't look like there's a bias. It's not really the QR code issue, although that might be part of the issue, right? Maybe younger people know how to use QR codes. The bigger issue, though, I would say is that it's being read in a particular magazine, right? Different magazines have different readerships, just like different news shows have different readerships. And if you're doing something on Fox News, you're going to get a different opinion than MSNBC or ABC News. And if you're reading The New Yorker, there's going to be a different opinion than for The Atlantic, right? There's different readerships. So even if it seems random, the US magazine itself is not random. It's not something that everyone's reading. There's no magazine that's a perfect representative sample, right? Even Time, which is very popular, It's just not everyone reads that across the country. So that's what makes C it. And that's the type of answer choice you're looking for when doing a question like this. Okay. So I think we have one more and then we'll be done. All right. So in this one, right, our last one, right, only 8 question types in this whole category. And if you know these 8, you can really ace this category. And you're going to do this for all of them, right? Percentages, algebra, advanced math, geometry, bit by bit. I'm going to cover them all. And if you can do all the types I have, there's no reason why you can't get an 800 on this. So to determine the mean number of skateboards per household in a town, Omar surveyed 30 families at a skate park. For the 30 families surveyed, the mean number of skateboards per household was 3.2. Which of the following statements must be true? A, the sampling method is flawed and may produce a biased estimate of the mean number of skateboards per household in the town. B, the sample size is too small to make an appropriate statement about the number of skateboards per household in the town. C, the mean number of skateboards per household in the town is 3.2. And D, the sampling method is sufficiently random and likely to produce an unbiased estimate of the mean number of skateboards per household in the town. So I'm going to eliminate C, right? It can't be that precise. There'd be some margin of error, even if they did a beautiful study. So is the sample size too small? Possibly it's too small, but let's look at the other things, right? Is it a perfect, sufficiently random, and likely produce? Maybe. But is it? So we want to think, what could be throwing off this sample, right? And the thing that could be throwing off the sample is the location where it's taken, right? At a skate park. Who goes to skate parks? Skateboarders, or people who are friends with skateboarders, or people who are family with skateboarders. So you're going to have a much higher number, I think, of skateboards than you would if you did it at like a retirement community, right? Or at a swimming pool where the water's filled up and not empty for people to skateboard in it, right? So it is biased because of the location. So the sampling method is flawed and may produce a biased estimate of the mean number of skateboards. And you could even probably say that the bias makes it go up, but they're not asking for that, right? They're just asking if it is biased, and it is. So again, this one's kind of a tricky one. Probably the second hardest one, I think, besides B, because you can tell it's biased, but I think the answer choice here of B feels tempting because 30 families maybe is too small, but the bigger issue is the location makes it a bias. So again, these are 8 questions. The video is not too long. If you conquer this video, you know how to do this type of question. There are more in the question bank. These are all questions that I created based on it to sort of maximize impact on learning. And if you want to see more like this, let me know. More videos like this are going to be coming. And if you have questions on any of these, always feel free to ask me. I'm happy to help. Otherwise, I hope it is sunny where you are. And if it's raining, I hope the rain is cleaning your windows and watering your plants. Bye.